Very good day, everyone. So today I will demonstrate to you how to implement uh, in C the uh, process synchronization problem, especially on dining philosopher problem. DPP is one of the classic problem in process synchronization. Um, as stated in the textbook, there are three methods that you can use to solve this problem. One is through mutex lock. The second one is using a semaphore, and the third option is using a monitor. So first of all, I'll show you how to implement it in C using a mutex lock. So in C, you first you need to include all the library, and then you have to define the number of philosophers. So in this case, we specify 5 philosophers, and then you have to declare the structure of the chopsticks. So this is where you declare the mutex. So using this library, this data type that is provided in pthread library, and then define the structure of the philosopher that contain three elements, which is the ID of the philosopher and chopstick on the left and on the right side. And then you have to define the function thing. So for this one, it is randomly from up to 1000. The sleep time is specify up to 1000 sleep time. Similarly for the it function, so basically we just simulate the it function with random sleep time. And then the thread function, we call it the philosopher routine. This is where the thread function will be called. The idea is to have a loop, infinite loop, and this is always true. And then based on the ID, if it is the ID is even, then the order is to pick up the left chopstick first, followed by right. And for the philosopher with odd ID, they will take the right chopstick first, followed by the left. And then after that, they continue with thinking, eating, and then put down the chopstick in reverse order. Now you may wonder why I put it through here. So this is to make sure that I just want to demonstrate that what happens if all philosopher simply pick up the left and right chopstick. So the order is always left and right. So that's why I make it through here. So this is just to demonstrate what happens if we do not split the philosopher between even and odd ID. So when I put through here, that means this statement is always selected instead of the second one here. Now in the main program, you have to initialize the chopstick itself. So it should be 5 equal to the number of philosopher. And then you initialize the pthread mutex. After that, you create a thread. So each philosopher will have their own thread. So here is the initialization and creating the thread, followed by pthread join and destroying the thread. So if you okay, let's compile this one and see what is the output. So you can use this command to compile. This is mutex.c. Don't forget, you have to specify this option. So we successfully compiled the program. Now if you run this program, so you have this problem. This is deadlock because each philosopher pick up the left joystick and then they are all waiting for each other to release left joystick so that one of the philosopher can proceed with eating. But since everyone is lifting the left joystick, so they are all waiting, so we have a deadlock here. If you run this again, but sometimes it works, so it is not guaranteed. It is not guaranteed. You run again, this one you have the deadlock again. So what happened here is in some run it works perfectly, but in some in other run you will get a deadlock. So you can try this for several run. So it is not guaranteed. So in some run it seems to work, but this one after some run it gets stuck. So this is what happens if you did not split the philosopher based on the idea. Let's try remove this. Let's try remove this one, and then recompile the program, and let's see what happens. So run, try another run, try another run. So it's more stable, much better. So basically you avoid the deadlock where everyone pick the left joystick by simply dividing the philosopher between odd ID and even ID. So you can apply the same technique for semaphore here. For semaphore, similarly, but instead of using pthread mutex, in semaphore you declare a semaphore using that is provided in the semaphore library. The rest are very similar, except for monitor. The solution for monitor is quite different. You don't have this problem of lifting the left or right. In monitor is because it is controlled by the monitor, so you don't have that problem. Okay, that's all for this tutorial. I'll share the code and you can try it out yourself.